But if you have special cases or items, you need to special or reasons for later submission, you can send me email to explain. Okay. Next example. If the motor turns gear A with an angular acceleration of alpha A is 2 radian per second squared, when the angular velocity omega A is 2 radian per 20 radian per second. Okay, omega A is here, right? Angular acceleration. Okay, same, not a deceleration, right? Same direction. Determine the angular acceleration and the angular velocity of gear D. Okay, gear D. Okay, by the way, let me explain, because you should know uh, the deadline is reasonable, because actually before you come to the assignment one, you already have enough knowledge and skill to solve those problems. If you need a little bit more uh, raw materials or new things, you need to have a preview of the new parts. Okay, and this percentage is not in a high percentage, right? Because during the and I already give you a lot of hints, right, and the tips during the past lectures. There's no reason to pass this deadline. And it's not the middle. We are not the middle school. We are in the college teaching, the university teaching. So you need to deal with the new engineering problems as an engineer. Okay? It's a task, not just a test or question, right? Because for assignment, you have free time. Right? You have free time. You can check on the website. You can check the textbook. You can check every raw material you need. You're free to use these resources. It's not a test, not an examination, right? If the test is out of range, it's maybe not reasonable, right? Because we haven't learned it and it appear on the test. It's not fair, right? But for the assignment, it's very common to have new things, right? But I can control this percentage, the ratio of the new things. So you need to speed a little bit up. Okay, back to this question. Gear A, B, C, D. Okay, from A to B and to C and D. So omega B and C share the same shaft. Therefore, omega B equals to omega C, right? You need to know omega B equals to omega C and alpha B equals to alpha C. And then we need to build a chain, right? We can use the chain of ratios, right? Chain of drive ratios. So you see, we want gear D, right? So we want gear D. We just put omega D here. Okay, we just put omega D here. Omega D, and we know omega A, right? We just put omega A as the denominator. Okay, so omega D over omega A. What is the path? Firstly, D to C, right? And the C is adjacent to B, it's a neighbor, right? And then B to A, right? Therefore, we can write like this. So omega D, put it here, over, and then start the chain, right? Omega D over omega C, because we have omega C to be divided, right? So we need to times omega C, right? And then C to B, right? Omega C, and we just divide it by omega B, and then time omega B, right? And then omega B divided by omega A at last, right? Omega A. So we just write down the ratios and do it one by one. Omega D over omega C, right? RC over RD, right? RC over RD. And the second one, omega C over omega B. Omega C and omega B, they're on same shaft, right? So this two gear has same angular velocity, which is 1, right? Last one, omega B over omega A, RA over RB, right? Just upside down, right? So, okay. And the ratio is, we just substitute. RC is 50 millimeter, right? And the RD is 100 millimeter times 1 and times RA is 40 millimeter and the RB is 100 millimeter, right? So at last you can get a ratio, right? The ratio is a number. Half times 0.5 times 0.4 equals to 0.2. 0.2 is the ratio. So at last omega D is 0.2 omega A. And you can find omega D, right? It's 20 times 0.2 radian per second. Actually, it's 4 radian per second, right? And also alpha D over alpha A, alpha D over alpha A, because they're in the same chain, right? Alpha D over alpha A has the same ratio as omega D over omega A, so it's 0.2. Therefore, after calculation, you find alpha D is also 0.2 alpha A, which is 2, right? Radian per second squared. It's 0.4 radian per second squared. Okay, this is the answer. Okay, and the last one. So we have a motor, right? And the power output is on the shaft C, right? The pioneering gear A on the motor shaft. Okay, A is on the motor shaft, and constant angular acceleration alpha. If gear A and B have the dimension shown, okay, A has the radius 35 millimeter, B has a radius of 125 millimeter. Determine the angular velocity and the angular displacement of shaft C when t is 2 seconds, starting from rest. Okay, so we can just find A first and just then do the ratio, right? It's quite easy. So for wheel A, right? For gear A, so alpha is 3 radian per second square, what we already know. Omega is omega 0, right? Omega when t is 0, initial plus alpha times t, because it is a constant angular acceleration. So it is 2 second times 3, which is 6 radian per second square. So finally, you can get it, right? You can get alpha A and omega A. And alpha C and omega C, you just use the ratio, right? So because it's the ratio uh, between the radius of these of those gears, right? Oh, the last one is angular displacement, right? Angular displacement actually is the angle, right? We also need to know theta A, right? Theta A is the same, right? It's omega, initial omega times t plus half alpha times t squared, similar to the displacement of a particle, right? Similar to the particle displacement. Oh, sorry. Similar to particle displacement, which is S is V 0t plus 1 over 2 AT squared, right? Similar to the displacement of a particle, what we have learned. So theta A is omega 0 is 0, so it should be 0 plus half AT squared. A is 3, and T squared, T is 2 squared, okay? Which is 6, right? 6 radian. Okay, this is the theta A, and the ratio are same. Okay, theta C over theta A is RA over RC. Okay, the all in same ratio, and just do it same ratio. Okay, that's it. Any questions for this part? If no, we switch to the next part. Oh, before we come to the next part, you should know in this up to now, what we have learned, right? And from the beginning, we have those formula, and together we learn the drive ratio, right? We learn the drive ratio. So you can add the drive ratio to this formula list, and for yourself, for the self review, in preparing for the test, right? In the future, okay. Okay, then we come to the new topic. It's a relative motion. And for the relative motion, we may need today's lecture and maybe one more lecture. Okay. And okay, so firstly, we talk about rotation. This is what we have learned, right? So what we have learned rotation for a couple weeks, all right? And we analyze the relationship between angular something and something, right? And for a rigid body, we know what is a rigid body, and we are now familiar with all the rotation related items. So there's no more words on it. And for the rigid bodies planar motion, there are two types. Okay, so now we are talking about the planar motion of a rigid body. So for the planar motion, actually is a body moving in a plane. Okay, it does not have a angle change, just move in a plane. So for the planar motion, there totally can be decomposed, has a decomposition of two parts. First one is a rotation. The second one is translation. Just these two. Okay, so it can exist independently. Okay, just only rotation, no translation is okay. Right, what we have learned, and the only translation, no rotation, also okay. Okay, so if we put them together, okay, we got another complicated motion. We call the general plane motion. Okay, 一般平面运动。So it is rotation and translation that happen together on a rigid body. So we have a general plane motion. So finally, there are three types of motion. We have learned the rotation, right? We have learned rotation. And then we introduce translation and general plane motion, those concepts. And firstly, the translation. So what is the translation? There are two types of translation. One is rectilinear translation. Okay, the other is curvilinear translation. Translation in Mandarin is 平移, right? 平移. Rotation is 转动, right? So for rectilinear translation is very easy to understand, and what you can imagine for a translation is this type, right? For a rigid body here is a rigid body. It just moves from one position to a new position, right? And maybe later it come to here, right? This board come to here, and we call this as a rectilinear translation. So what is the property or characteristic of translation? The only characteristic of translation is that every point can represent the body's motion. Okay, in translation, every point can represent. See, the conclusion is in translation, every point has same motion, has the same motion. Okay, all the particles on the rigid body has the same motion. It can move in a rectilinear way. It can also move in curved paths. Okay, it can be straight paths. It can be in a straight path. It can also be in a curved path. Curved path. So left-hand side is a straight path, right? So if we look at these those particles on it, if we look at the left top particle, right, and it moves to here, so the path is this one, right, the black one. And if we use the red one, and the middle particle here, right, start from here and end at here, right? So the path is this one, right? And if we use a green, okay, for the edge middle point, now it comes here. So you can see also. So let's say this one is the path L, and this is path L prime, and this is the path L double prime. And we know L and L prime and L double prime actually the same path, right? The same path. Same. This is the rectilinear translation. The other is the curvilinear translation. Curvilinear translation, let's see the motion of this rigid body. Here we have three rigid bodies, okay? And this is the fixed one, okay? We just fixed here. And we have on the left hand side, we have a rod A, and on the right hand side, we have a rod B, right? And on the bottom, we have a plate. We have a plate. So totally three moving rigid body. For rod A and rod B, they are in what kind of motion? What's the motion of rod A and rod B? Oh, there's no such animation. Can you imagine that? They're in the parallelogram, right? And we fix this point here and fix this point here on a pin. Okay. Here we have a pin, and here we have another pin. Okay, and then fixed on the wall, and this two rod pin to a plate and move together. So let's look at this motion. Maybe we can switch to the SolidWorks with me for a second. Wait a second. Okay, let me just open it and share with you what happened here. Can you see my screen? See, it just here we have a plate, right? We have a plate, and as you can see, we have a gray plate fixed at background, right? The gray plate, this one is fixed, and we have two rods, right? 两个摇杆, two rods is two red one, and last we have a plate, right? In dark yellow color, and we can see when we have traced four particles here, right? We have traced this one and this particle, right? And this one and this corner, right? Two corners of the board, this corner and this corner of the board, right? also we have traced two rods end, right? This pin and this pin, right? And this two rod. And as it moves, we can see concentrate on the board. Do you find that every point we have traced, have same path, right? All the points we traced have same path. Can you get it? Do you know what I'm saying? You should know every point here share same path. Where is my chatting box? Okay, and let's come back. So this is also translation. It's also translation. So for a translation, what is the benefits of translation? As all the points have same path, same velocity, same acceleration, right? In translation, as long as the rigid body is in translation, okay? It's in translation. It can be curved translation or rectangle, right? Rectilinear translation. So as it has a translation, all the points, okay? All the points on it have the same displacement, same velocity, and same acceleration. For example, we have a mechanism like this. Okay, here is a parallelogram, and we have a rod here, another rod here. Okay, so we link these two rods together with a plate. Okay, with a plate here. Okay, to link up these two rods. And we have a red pin here, another red pin here. Okay, so here is a pin, and here is another pin. Okay, pin 2, and here the also pin connection, right? And this is the fixed point. Okay, fixed point, and this is the A, this is the B, and this is the component C. Component C is in the curvilinear translation. So we take this point as is the point P, okay, point P, and this pin is a point Q, and in this motion, we should you should know velocity P totally equals to velocity Q, okay, and acceleration of P totally equals to acceleration of Q. And it has two parts, right? Acceleration of P. So it has acceleration of P n equals to acceleration of Q n. And the acceleration of pt equals to acceleration of qt. Okay, everything is same as long as the rigid body is in translation. Okay, and every motion, you know a point, you know the whole body. Okay, that's it. And let's come to the general plane motion. When a rigid body is subject to a general plane motion, okay, it undergoes a combination of translation and rotation. Okay, translation and rotation. So this is it should be a cartoon. It should be a yeah. So we need to find the animations of those motions. Okay, there are totally okay. We consider four types of general plane motion. Okay, it has it has two important things, and it has rotation. Okay, in a general plane motion, it has a rotation. It means when you consider the component, there's an angle change. There's an angle change, and it has a translation. It also have a translation. So when you remove the rotation, the translation means there will be a position change. Okay, will be a position change, and generally we consider four types of general plane motion. The first one is what we call double slider. Okay, so when when point A, right, when point A slide along this rack, and point B, this is a point B, slide along another rack here, this rack, right? Therefore, the linkage AB is in a general plane motion, right? The linkage AB is in general plane motion. Why? For one thing, it has an angle change, right? When you can imagine a ladder, right? 梯子 ，OK，一个梯子，它立在墙上 ，OK。When a ladder slide down, when the ladder slide down, for one thing, there is an angle change, right? From maybe a vertical position right here to to another position with a gentle angle, right? So in this motion, there is a angle change. For another, there is a angle change, but not a pure rotation, all right? But not a pure rotation, and we take it as a general plane motion. So another one is a crank slider. Okay, crank slider. For a crank slider, we can see the link AB, the link AB here, also in a general plane motion, also in a general plane motion, right? Because point A moves up and down, and point B in a circular motion, right? When we link AB, and AB has a angle change, also a position change, right? So it is subject to a general plane motion. You should think about the two questions. So you can identify general plane motion from a rotation. The second one is you can identify general plane motion from translation, from curved translation. Okay. it does not have a curved rotating center, right? A fixed rotating center. So it is not a rotation. It does not, for 2 points, it has different motion. So it is not a translation. Therefore, it's general plane motion, right? So again, for double slider, point A is in a linear motion, right? Linear motion. And point B also in a linear motion, right? Curvilinear motion. Oh. Rectilinear, right? Rectilinear motion. And for crank slider, point A has a rectilinear, but point B has a curvilinear, right? Curvilinear motion, right? And if 2 points, if two endpoint both has a curvilinear motion, and AB, the link AB, also in a general plane motion, right? The last one is different from the first three, right? Last one is we call the rolling. In a rolling wheel, this wheel is experiencing a general plane motion because for one thing, it rotates about its center. For another, it has a position change, right? It rolls to the rolls forward, right? And it has a horizontal velocity. So in the following, today and the next lecture, we will talk about these 4 types of motions. Okay. So we talk about relative motion of velocity and the relative motion of acceleration. Okay. So today we continue on the relative motion in velocity. Before we continue, we just check these animations. A second. The animations, we can find it here. Okay, and let's look at those animation. Okay, so for the what we have mentioned, okay, a rectilinear translation will move like this. Rectilinear translation, right? It just move from one position to the other position. Okay, it just say it move in a straight line. The path is a straight line. And for a curvilinear translation, it just rotate like this. All right. So as you can see, in such a motion, the rectangular plate is experiencing a translation. Okay, translation. Okay, so when coming to the four types for general plane motion, you see for the first one, okay, you look at the linkage. Look at the linkage, link up 2 points. Okay, the linkage is in a general plane motion because, okay, one more time, because it is not a rotation, right? If it is a rotation, there must be a fixed axis it can rotate about, but there's no, right? Therefore, it is not a rotation. Is it a translation? It's not a translation, right? For this rod AB. AB is not a translation because if it is a translation, point A and point B should have the same traveling paths. But now it has distinct traveling paths. Therefore, it is not rotation, not translation. There's only one possibility, right? One answer, which is general plane motion. For the second one, same. So we just focus on the rigid body AB. Okay, the rigid body AB. I mean the linkage, okay. So for this linkage from A to B, also it is not a rotation, pure rotation, right? If it is a pure rotation, there must be a fixed axis it can rotate. No, it's not a translation, right? Because a point A and a point B has a different motion, right? Point B is a straight, right, moving on the straight line, and point B moving a curved line, right? The third one, we call it a full bar linkage or a crank roller. Okay, so as you can see, for the link AB, okay, still the link AB, point A moves along a curve, right, circular path. Point B moves along another curved path. So it is not translation, and no, neither translation, no rotation. Therefore, we call AB experiencing a general plane motion, right? But the left rod and the right rod, okay, it has a pure rotation, right? It has pure rotation. The last one, rolling, okay, when the wheel rolls forward, right, rolls to a position, to a direction, it has a position change, right, and also it has a angle change. Therefore, we call this rolling also another type of general plane motion. These four types of general plane motion contains almost every aspect of general plane motion. Okay, so it's very useful for problem solving. That's why we summarize them together here. Okay, and okay, let's continue. Okay, so in such a general plane motion, what kind of problem we're gonna solve? Okay, in a general plane motion, we need another blank page. So we have again for rotation. If we know, so now the question is, we want to know for a specific particle, the particle P. We want to know velocity P and acceleration P. Okay, velocity P and acceleration P. So this is the question. We want to solve such a question in the engineering application. Okay, for a specific particle p, we want to find velocity p and ap. If it is in a rotation, okay, if it is in a rotation, actually it's easy, right? And vp is omega r, right? Omega r. We just use a vector, okay? We just use vector. And the AP is alpha cross R plus omega cross V. This is what we already know, right? OP. OP. And if it is in a translation, right? If it is in a translation, translation is also quite simple, right? Because in translation, we know all the points in the same motion, okay? So VP and AP are same to the given points. Okay, this is in translation. Translation is very, very simple, right? It's the easiest one. If it is in translation, actually we just know one point. We know every point. But in rotation, it's not, right? In rotation, for different point, there are gonna be different motion, right? And the last one, if it is in, so what we care about today is last one is in a general plane motion. General plane motion. Okay, in general plane motion. So how to deal with it? The question becomes given, okay, given VA, okay, for a given point, okay, given VA, AA, okay, give a point, information, and we want to find the VP, okay, for the unknown. We want to find VP and AP. And rigid body's motion, right? Given the rigid body's motion, omega and alpha of the rigid body, right? And we find the VP and AP. Therefore, the VP and AP can be divided by two parts, okay? So if those are given and we need to find them, okay? We need to find the VP and AP. Actually, VP and AP has two parts. The first part is from translation of the rigid body. The second part is from rotation of the rigid body. Okay, and now we can do the analysis. Okay, we can analyze the velocity first. Okay, let's see. What are we gonna do? So we want to know VB. Okay, given VA. Okay, we want to find VB. We want to find VB. In such a case, we start from the displacement analysis. We call it the decomposition of the motion. Okay, so we call this one as the motion's decomposition. You see, this part is very critical. Okay, so let's see what happened. Originally, and there is two points. Okay, two critical points. One is point A, the other is point B. Okay, the other is point B, and we use these 2 points. We can uniformly identify the position, right? Determine the position of such a rigid body. Okay, we can use A and B to locate the body. All right. Okay, so later, as time goes, what happened? As time goes, point A comes to here. Okay, point A comes to here, and the point B comes to here. Okay, you can see point A and point B is in distinct motion, right? Point A along one curve, one line, and then point B moves along the other line, right? And therefore, we know AB, the link AB, or rigid body AB, okay? The link AB has a general plane motion. 它有一个什么一般平面运动 ，okay, general plane motion. So we given VA, we want to find VA and VB's relationship, and we continue. Okay, continue. So this motion can be regarded like this. Okay, what's that? Firstly, we can take it. Okay, in the green parts. Okay, we just focus on VA. Okay, we just focus on RA. So A moves on the red path, comes to here. Okay, A to the new A, right? A to the new A, and B. Okay, we just repeat this this one. Okay, we just repeat this one. Repeat this one. So B comes to the new B. Okay, we call it B prime. Now, so we call this one as step 1. After step 1, AB comes to here, right? Comes to step 1 is from AB now to AB prime, all right? AB prime. This is step 1. What is the motion of step 1? What is the motion of step 1? Point A move to the new A, right? Point A move to the new A. Point B moves to the new B, right? B prime. And A and B move in the same path. So what is the motion of this step? It's what? Okay, we got the answer. Any other idea? Of course, right? It is a translation. Very good. So of course it is translation, right? So step 1, we just write down here. So step 1 is translation. As A and B move in the same way, right? Okay, now let's experience another motion with step 2. Step 2, let's take in A as a rotating center, and let AB rotate about A. Rotate about A to point B. Rotate about A, so B prime to point B, right? We call this rotation as step 2, right? So step 2 is a rotation about A. So therefore, we can have such a decomposition. I just highlight here. So the general plane motion of AB, right? The general plane motion of AB is a translation with A plus rotation about A. Is it clear? For this page, for page 8, okay, for this page, can you understand this highlighted part? Okay, good. It's very important. It means for any general plane motion, it can be a combination of a translation and a rotation. If this makes sense, then the general plane motion is going to be very simple. Okay, let's see. If we know this step 1 and step 2, and we can have a motion like this. So let's look at the motion of particle B. Okay, particle B. So particle B has 2 parts. Okay, so firstly, particle B experience a same as A's motion during the translation, right? Due to the translation with A, right? During the translation, this part is from the translation because A and B has same motion, right? And then B prime have a curved motion about A, right? Has a curved motion about A. Therefore, we have the second part due to the rotation of the rigid body, which is B rotate about A. Okay. So we have this part of motion due to the rotation. Therefore, we put them together. Okay, we sum it up in vector. Okay, sum it up in vector. We have the motion of a particle B. Okay. Now let's look at the final one. Okay. So DRB is the displacement of B, right? Displacement of B equals to first one. This one is what? Is the displacement of a reference point. Reference point A plus what? This is the relative motion and the relative displacement of B with respect to A. With respect to the reference point. Okay, so totally there are three parts. Okay, so for one thing, we have we want to study point B's motion. So point B's motion has two parts. Firstly, it's a reference point's motion. Secondly, is the relative motion about the reference point. Is it easy to understand? It's not easy to understand, right? So after class, I need you to pay more attention to this page, okay? And we can use some plan, okay? And let's see. So we have a motion like this. So general plane motion actually can be decomposed as a translation and a rotation, okay, and a rotation. So a general plane motion is a translation, okay, we're taking A as a reference point, okay. Now we're taking A as a reference, okay, as the reference point. So it has a translation with the reference A and the rotation about A. So there should be uniform, okay? So if you taking A as the reference, okay, you always use A, okay? Don't change the reference, okay? The reference should be consistent, okay? Now, okay, let's see. For the translation with A, okay, translation with A, it has a contribution of point B's motion as velocity A. And the rotation about A contribute the relative motion of particle B, taking A as a reference, okay, with respect to A. Okay, so this part we have VB. VB is omega times RBA. Omega times RBA. So therefore, we combine them together in vector. We have the velocity of B equals to velocity of the reference plus omega cross the position vector of B, taking A as a reference. Okay, so RBA B slash A, right? What it means? It means R, okay, R is here, and B is the target point we analyze, and the slash A is the reference point. Okay, so RBA always equals to R from A to B, also equals to from A to B. Okay, you should remember a reference point is also a initial point. In the position vector, okay? So RB slash A, take A as a reference, okay? It is RAB or AAB. Okay, to get it more clear, we just use a double slider to do the analysis, okay? And we may look at this one, okay? We may look at this one. Give you 2 minutes. Okay, so let's look at this example. And what are we gonna do in a general plan motion analysis? Okay, so this is one of the four typical general plan motion. The double slider one is the most simple one. See, here we have a link. This link is link ABC, right? Link ABC. This link is in a general plan motion as a slide down, right? Point B slide downward. Point A slide to the right, right? Point B slide downward, and point A slide to the right, right? Slide to the right, and then point C in a curved motion, right? Point C is in a curved motion, and so this kind of question we always be given the velocity of one point, okay, and give the geometrical relation. And what we want to know is the velocity of another point. Okay. Therefore, if point B is given, you can how to analyze this? You can take it as this, right? So firstly, move. So the motion, okay, the initial position is here, right? Initial position is here. The terminal position is here, right? So from the initial position to terminal position, it can be divided as a step one, translation, and the step two, rotation, right? So we know the reference point. Okay, we can take one uniform or one consistent reference point, taking B as a reference point. So firstly, translation with B. Okay, everyone translate with B. So point B moves downward as due to the rack, right? Due to the rack, and in such a translation, everything point A also follow point B. Okay, that it's a virtual one. Okay, it's a virtual motion, right? And second one, everything rotate about the same reference point, about B. Okay, rotate about B. So point A comes here. You see, initial position is this position, right? Initial one is this one. Terminal one is this one. Therefore, translation with B plus rotation about B equals to such a general plan motion. Okay. Therefore, it's easy to explain VA, right? How to find VA? We can see VA A is a target point, right? A is a target. Target point's velocity has two parts. First part, I just use black, is the reference point's velocity, right? Is the reference point. Plus, I use the red one, plus the velocity of A taking B as the reference point, right? So to better remember this one, okay, and it's easier for you just take it like this. We can do a swap, right? Swap will be so this is easier for you to remember this, right? So VA, okay, taking A just as is absolute motion, right? Absolute motion VA. equals to VA, right? Uh, V equals to VA, absolutely, right? And here, but we have a reference, right? Taking B as a reference, taking B as the reference. Okay, so if if it is not a VA, it's a conditional VA because it's a reference, it's a relative VA, right? Plus the reference velocity. Okay, this is a relative VA. Okay, so we can expand this equation as what? As VAB. Actually, it is the angular velocity of this rod cross cross what? Cross the position vector of A, taking B as a reference. Okay, taking B as a reference, plus VB. Okay, plus VB. Now we have only one equation, right? We have only one equation. Based on this equation, we can solve the problem. Okay. So how to solve it? Actually, we do not know VA, right? We can do it one by one. Okay. So finally, we have such an equation: VA equals to, okay, equals to omega AB, right? Cross R A taken B as a reference plus VB. So in this case, we can analyze one by one. Up to now, can you accept this idea? Can you understand how many percent can you understand? Can you obtain? Is there more than half, more than 50%? Can you understand more than 50%? I just give you 2 more minutes. Okay, 80%, good. I give you 2 more minutes. If you have questions, you can type here. You can type your questions. Okay, so let's look at this this formula will be given. Okay, actually, if you understand, there's no need to check the formula list, right? If you understand this equation, it's easy to find out the to write down the formula like this, right? Okay, so let's analyze one by one. Okay, we start from the VA. Okay, for VA, we're gonna analyze, and for because they are all vectors, right? Because they are all vectors, and we need to analyze in two aspects. Firstly, the direction. The direction is given, right? Direction is given. We know it's to the right, right? And VA for the velocity, right? The speed, the magnitude is not given, right? Not given. We just use a question mark. This is the VA. Okay, the second one, omega AB. Omega AB also a also a vector. It also has two parts. Firstly, the direction. Is it a given? Direction for omega AB. Omega AB. So how to identify omega AB? This rigid body has an angle change, right? From one angle to the other angular position, right? It doesn't have, if we link any points, right? Any 2 points, there will be an angle change. And this change is from one angle to the other, right? So when it rotates like this in such a rotation, the direction, do you agree with me that the direction actually is counterclockwise? We know the direction, which is counterclockwise, and it can be positive k. Agree with me? If you agree, please type 1. If you don't know, you can keep silent. Okay. Omega. Because the omega, okay, so we just said this is y, this is x, okay, and this is x. So because the rotation is in the rotation is in x y plane. Therefore, the axis of rotation must be in z direction, right? Positive z or negative z. Agree with me? 可以理解吧？就是它这个旋转，它是发生在这个 x y 平面内的一个旋转，所以你不管它怎么转，它的 axis 肯定是沿着 z direction 的吧 ？Anyone here? Yeah, not just the right hand row, not to the right hand row. You see, if something rotate on x y plane, OK， 如果一张纸 OK 在 x y 平面内做旋转的话，你不管它怎么转，它的 axis 肯定是平行于 z 的吧，对不对？它不会 along x， 因为你自己拿你的 iPad 或者是拿一张纸转一下，你在桌面上转一下， 如果一旦这张纸在桌面上发生转动的话，那它的这个转轴一定不在桌面上，一定是垂直于桌面的。你首先要清楚这件事情，所以说你这样才能够特别自信的写出这个 direction。Okay, okay, that's it. Okay, so for the magnitude is not given. All right, not given. We can assume it is the omega AB. Right? We can assume it is omega AB. And for the VA, we do not know VA, right? The magnitude, and we can assume it is VA. VA the scalar, right? Now, for VA, we know the direction, but we can assume it is VA, right? Magnitude, I just use text in in case some of you are absent from the lecture, right? Magnitude, we can see don't know, right? Don't know. Assume it is V8, okay, taking V8 as. So combine together, we can have VA as like this. So VA, the assumed magnitude with the direction. Direction is to the right. To the right is positive I direction, right? Because we have the coordinate system. Therefore, VAI is the vector of VA, right? And omega AB, so omega AB, we put them together. It is a assumed omega AB, right? We do not know the magnitude, but we know the direction. Direction is along K, right? Positive K or negative K is okay. Because omega AB is here as an unknown. So if it is a positive, after the equation solving, we can solve a positive number. If it is negative, we can solve a negative number. This doesn't matter. Okay, so this is omega AB. The third one, okay, with blue. Third one is RAB. Okay, RAB. I just link it out here. Okay, RAB, RA taking B as the reference. Okay, B is the reference, also the initial point. Okay, so RAB is totally given, right? RAB actually is from A to B. Oh, sorry. RAB is from B to A. B is the initial point, right? B to A. B to A is totally given. From B to A, we should use this position, okay? At this instant, we should analyze this instant. From B to A. B to A, firstly, along Y downward here, okay, along Y downward to the A level, and then along X to the right hand side to A. So BA, the vector is this one, right? The vector is this one, BA. The BA vector is, you see, I use point D, is BD plus DA, right? BD is negative, what? Oh, here is VB, sorry, right? BD is negative 0.2 times cosine 45, right? This one, BD is negative 0.2 times cosine 45 J, right? And DA is positive 0.2 times sine 45 I, right? So finally, we have BA is positive 0.2 sine 45 I minus 0.2 cosine 45 J, right? So we know everything about BA, right? Then it's a meter, right? 1, 2, 3. The last one is VB, okay? Last one is VB. We just use the green color, okay? We talk about VB. VB, do we know the direction? Yes, we know the direction. We know the direction, VB, all right? It's downward, all right? Here, it moves downward. And the magnitude also given is 2. So at last, we know the direction is downward negative J, all right? And the magnitude also given is 2, right? 2 meters per second. So at last, VB, we can clearly show as 2 negative J meter per second, all right? So up to now, we can highlight what we have. So in such a formula, for each item, VA, omega AB, RA slash B, and VB, we can get VA, okay, is a VAI, right? And omega AB is the omega ABK, okay? RAB is this one. And last VB is this one. So there are two unknown, VA and omega AB. So we put them together. We put them together. What do we got? We got VAI, right? VA, we do not know the magnitude, but we know the direction. VAI equals to omega AB is the omega AB K cross RAB cross 0.2 sine 45 I minus 0.2 cosine 45 J, right? Plus VB, right? Plus VB negative 2J meter per second, right? We just neglect the unit because they are all SI, means international unit system, right? And then we solve this equation, we can find VA, right? After solving this equation, we can find VA, all right? So how to solve it? Actually, we can expand it first. Firstly, continue. Left-hand side, we have VAI. Right-hand side, okay, we do the cross product. The red one, okay, omega AB times 0.2, right? Omega AB times 0.2 is 0.2 omega AB. K cross I, which is positive J, right? Positive J. And then omega AB K cross the later one, right? Omega AB cross this one is oh sorry, we have sine 45, right? Okay, the second one, negative 0.2, okay, negative 0.2 cosine 45 times omega AB, right? Then K cross J is negative, sorry, K cross I is positive J. All right. K cross J is negative I, right? It's negative I, so we just use negative I plus, right? And then plus the minus, right? So we got minus 2J, right? Minus 2J. So finally, we combine I component together and the J component together. So for left-hand side, we have VAI. For right-hand side, we have I component, which is highlighted in yellow, and the J component, which is highlighted in green. So at last, for I component is 0.2 cosine 45, right? 0.2 cosine 45 degree omega AB and I, right? I. And the J component is a plus. It has coefficient 0.2 sine 45 AB, omega AB, and minus 2, right? Minus 2 J. Okay. So you see, compare left and right. Compare left and right. Left-hand side, we have VAI. Right-hand side, we have so many I, right? Therefore, for I component, left-hand side VA coefficient equals to right-hand side 0.2 cosine 45 omega AB. And for J component, right? Because there are totally two components, right? For J component, it just for left-hand side, because VAI, there's no J is equals to 0J, right? 0J. So left-hand side is 0, equals to right-hand side is 0.2 sine 45 omega AB minus 2. Okay, and there we can solve these two equations, all right? And we can see there are two unknowns and two equations. And the two unknowns. It can be solved, right? At last, we solve it. So how to solve it is quite easy, because omega AB from the second one, we know it is 0.2 sine 45, right? Omega AB equals to 2, right? Equals to 2. And sine 45 equals to cosine 45, right? So after solving, we will find the VA is 2 meter per second, right? So at the last, VA is 2 meter per second to the right, or VA is 2 meter per second I. That's it. Okay, so because this is the first time we analyze this kind of problem and this kind of question. So actually, if you got familiar with it, it's gonna be very easy to deal with this kind of problems, right? We just use the formula and find out the items one by one. Okay, is it clear for you? Any questions? You can have any questions. If no questions, we just have a homework. So for you, you can analyze the homework. You can try it by yourself at home. Okay. Just let 5 minutes for you to digest and write questions. If no questions, you are free to go. Okay, you're free to leave and have a rest.
Sir.
Yeah. Hey.
I have something to ask about the assignment 1.
Good. Okay, good. Assignment 1? Later, okay. I just wait for the question from this lecture. If no question, you're free to leave.